So we're looking at our trinomial, and I notice that there's a 2, a 4, and a 16. First thing I can do is I can take out a GCF. Now I've got my trinomial and I can do the x method on it. So I'm going to set each of my factors equal to 0. I get x is 4 and negative 2. Okay, the last one, I'm going to factor this one. So I see that p plus 4, p plus 3, or p squared, so on and so forth, is my common denominator. So that 12p plus 19 doesn't really need anything. Now the next one has p plus 3, so it needs p plus 4. And the 5 has p plus 4, it needs p plus 3. Alright. Distribute it out. Alright, we'll see if we got any like terms. So 12p minus 3p is 9p. 19 minus 12, 7. Get all the p's together. Move 7 over. P is equal to 2. Okay. The next thing on our list was identifying vertical asymptotes, horizontal asymptotes, and intercepts for these rational functions. So on this page, you've got steps to figure out the intercepts. First thing you want to do is factor. Factor and try to cancel. Remember, the canceling created the holes and took away possible intercepts. So to find my x-intercept, after I factor it, I'm going to plug 0 in for y and solve the numerator. So this one I can factor down x plus 3 and x minus 3. So nothing cancels out, so I don't have any holes. But now I can find my x-intercept. So I plug 0 in for y, and I solve the numerator, the number on top. To solve that numerator, I'm going to move 1 over and make it negative. So my x-intercept is at negative 1. Alright, y-intercept, I plug 0 in for every x and solve for y. So I've got zeros in for everywhere I see an x. I'm going to plug that into my calculator, and I get negative 1 over 4 is my y-intercept. Okay? So I can't factor number 1 because it's an x plus 4. So I'm going to take the top, set it equal to 0, and I get an x-intercept at 2. Y-intercept, we'll plug zeros in for our x's. We'll put that into my calculator. When I plug that into my calculator, I get a y-intercept at negative 1/2. Alright, I can't factor this one. Nothing will ever multiply to be 3 and add to be a 2. So I'm going to have 0 equals my numerator. So x-intercept by negative 6. For y-intercept, we're going to plug zeros in for x. Set that into our calculator. We get a y-intercept at 2. Alright, next thing we need to know are asymptotes. Asymptotes are imaginary lines that graphs get really close to, but never cross. Asymptotes are found when graphing rational equations because there are so many rules about fractions. In your calculator, this would come up as an error. An error is an asymptote. There are 3 kinds of asymptotes: vertical, horizontal, and slant. We're focused on vertical and horizontal. Alright? To find vertical asymptotes, we want to look at the denominator. So, first thing we want to do is see if we can factor it, because we still want to create our holes and so on and so forth. So, I can't factor it, so now I'm going to set my denominator equal to 0. Remember, an asymptote is an error, and in math, you can't divide by 0. So that's where we want that error at, where it would be 0 at. So I set the 0, so I have a vertical asymptote at positive 3. Because if I went back and plugged 3 in for x, it's going to give me 3 minus 3 on the bottom, which is 0. And because you can't divide by 0, it's going to give me an error in my calculator, which is where my asymptote is. Okay? Alright, the next thing we've got to talk about are horizontal asymptotes. Horizontal asymptotes, to find them, you look at the before factored form, the original form of that problem. Then it comes down to rules. If the numerator is bigger than the denominator, and when I say that, I'm talking about the exponent, the largest exponent. If the numerator is bigger than the denominator, there is no horizontal asymptote, so it would be none. If the highest degree is on the bottom, then your horizontal asymptote is y equals 0. If the exponents on top and bottom are the exact same, then you make a fraction out of the leading coefficients. So, what that looks like. First thing I want to do is I'm going to find my horizontal asymptote because I don't factor for it. So, my highest exponent is a 1. Because it's the same, I make a fraction out of my leading coefficients. Alright, then I can simplify 2 over 1. So I have a horizontal asymptote at 2. Alright, for my vertical, I can't factor it, so I'm going to set the bottom equal to 0. And I have a vertical asymptote at negative 6. Alright, the next one, I can factor it. Alright, so, but before I really think about the factoring, I'm going to go back and look at my original version to find my horizontal asymptote. I've got numerator equals denominator in terms of exponents, so I'm going to set my fraction up over my leading coefficients. And that I can't simplify. So I have a horizontal asymptote at 1/4. Now I'm going to look for my vertical asymptotes. I'm going to set each of my factors equal to 0. Because 0 does not equal 4, that one's kind of pointless. But the other one I can solve for x, and I get a vertical asymptote at negative 2. Alright, so we've got the same exponents again. So horizontal asymptote, we're going to set up our proportion or our fraction at 1/3. Now for my vertical, I can factor. So I'm going to set them each equal to 0. That one means nothing because 0 doesn't equal 3. And I get a vertical asymptote at 4. Okay. Next one. Now we've got a little something different. The larger exponent is on the bottom. So when that is the case, you don't have a horizontal asymptote. So none. Alright, now we want to try to factor it. Alright, I can keep factoring my denominator, because that's the difference of squares. Alright, so my vertical asymptote, I know that 2 is going to ultimately mean nothing. So in this case, I have 2 vertical asymptotes. One at positive 4 and one at negative 4. Alright, last thing in this unit, we're solving radical equations. Radical equations are when they have the square root sign, or the cube root, or the fourth root. steps to solve are right here. We want to get the radical on by itself. Then we want to raise it to both sides of the power to eliminate that radical. Once we get rid of that radical, we just solve this solution for x. The last step is the important one, when we have to plug solutions back in. Because radicals kind of mess up things, we sometimes get extraneous solutions, meaning when you plug them back in, they don't work. So we gotta always plug them back in just to make sure our answers work. So, first step says to isolate the radical on one side. Well, I've got my radical, but I also have this plus 8 stuck on the outside. So I'm going to move that over, because I want to get it all by itself. Alright, my radical is all by itself. So now we want to raise both sides of the equation to the proper power to eliminate it. And in this case, the proper power is that 3. To the third power and I put that in my calculator, I got to be careful with that negative. I got to put -4 in parentheses and raise the whole thing to the third power. If I don't, it's going to mess up my signs. Now I can solve for x. So I'm going to subtract 2. And I'm going to take -66 and I'm going to plug it into my calculator. When I plug it in, I should get the answer of 4. When I do, I actually do get 4, so I know that -66 is my answer. Alright, last problem. Alright, step 1 says to isolate that radical. The radical is already by itself, so I don't have to do anything with that. Now I just have to raise it to the right power. Again, I'm going to be careful when I raise it to the third because of the negative. So I need to put -2 in parentheses. Now I can solve for x. And I'm going to take -1/2 and I'm going to plug it in. And if it doesn't give me -2, my answer is none. So when I go back and plug that -1/2 in, it actually does give me -2. So there's my answer.